Hello, everybody, and welcome to your very last set of notes for 2016. Yay! Don't get too excited yet, they are long notes. Sorry about that. You are going to need two pieces of paper for this, most likely, unless you write very small. So go ahead and get out your pieces of paper and a writing utensil. And at the top of our paper, we're going to put our title, Bonds and Compounds. And below that, we're going to write our essential question, which is, how do properties change when chemical bonding occurs? As usual, below that, we're going to make two columns. Smaller column is for vocab, questions, key points, important stuff like that. Your bigger column is there for your notes. That's where you're going to write everything down. And of course, at the very, very end, you are going to write a nice 3 to 5 sentence long summary. So let's jump right into it. Chemical bonds. Bonds are a force of attraction that hold atoms together. These are formed by sharing valence electrons between atoms. In our last set of notes, we learned that valence electrons are electrons in the outermost layer of the atom. So in the atom, you have a nucleus at the center, and the electrons orbit around that in different levels or different layers, different shells. There are many words to describe that. And the electrons in that outermost shell are called valence electrons. Atoms need 8 valence electrons to have a complete shell, and they will basically try as hard as they can to get those 8 valence electrons. There are only 2 elements that do not follow this rule, and those are hydrogen and helium. And that is because they are much smaller atoms, they have much fewer electrons, so they only need 2 to have a complete valence electron shell. And that's just because the atoms are so small they can't hold any more than that. All right, so how do bonds happen? And in case you're wondering where the notes you're supposed to write are, they are at the bottom of the screen. So basically, the way bonds happen is atoms want their valence electron shells to be closed. That means either empty or full. They either want all 8 valence electrons or they don't want any at all. So they will do whatever is easier to get a closed shell. They will either lose or gain electrons based on how full their valence shell already is. So for example, a very common compound is salt, sodium chloride. It has a sodium atom and a chlorine atom. Now, sodium has 1 valence electron. It is much easier for it to lose that 1 valence electron to get to 0 than it is to gain 7 to get to 8. So think of it as if the atoms are lazy. They want what they want, and they're going to do as little as possible to get it. Now, chlorine, on the other hand, has 7 valence electrons. It's much easier for chlorine to gain 1 to get to 8 than it is to lose 7 to get to 0. So again, they want either all 8 or they want nothing at all. So we have a few types of bonds that we're going to talk about. We're going to go through a little bit quickly for the sake of time. Covalent bonds. In a covalent bond, the valence electrons are shared. These form between nonmetal elements. It is possible for multiple electrons to be shared by the same atoms, and when that happens, it forms what we call a double or a triple bond. Compounds that are made with covalent bonds are called molecular compounds or molecules. And there are 2 types of molecular compounds or covalent bonds. There are nonpolar bonds, which is where the electrons are shared very evenly. The atoms are being very nice. They're sharing nice and evenly with no issues. With a polar bond, you've got one atom that is being greedy and is trying to hog the electrons. So it's trying to pull them closer to itself and away from the other atoms. So it's an uneven sharing happening. Next we have metallic bonds. Metals are kind of special elements. Basically, the atoms don't hang on to their electrons very well, and they lose them very easily. So this causes a special type of bond to happen, and this only happens in metals. So basically, when you have a solid, a metal solid, the atoms come very closely together, and they basically just let go of their electrons. Now, when an atom loses an electron, it forms what we call an ion. We're going to talk about those in just a couple minutes. But basically, you've got all of these ions, these atoms that have lost their electrons. They're all packed together, and all of the electrons are just surrounding them and kind of just drifting from one to the other. So it's a very interesting thing. So basically, a metallic bond is the attraction between a positive metal ion and the electrons surrounding it. And like I said, we're going to talk about ions in just a moment. Now, ionic bonds. Ionic bonds are when valence electrons are transferred from one atom to another. So basically what happens is one atom will give away an electron to another. So when we were talking about valence electrons, we talked about sodium and chlorine. Now, sodium has one valence electron. It wants to get rid of it, so it gets to 0. Chlorine has 7 valence electrons, so it needs 1 to get to 8. So sodium is going to take that extra electron that it has, and it's going to give it to chlorine. Now what happens here is each of these atoms, their positive protons are no longer balanced out by the negative electrons. So each of these atoms now has a charge. And a charged atom is an ion. So an ion is an atom that has either lost an electron or gained an electron. When an atom loses an electron, it gains a positive charge. When an atom gets another electron, when it gains one, it gets a negative charge. Ionic bonds will form between a metal and a nonmetal. And there are several types of ionic compounds, which we're going to talk about. So ionic compounds are made up of a positive ion and a negative ion held together by an ionic bond. Now, like I said, ions have a charge. All right. Now, the charges of the ions held together will balance out. So sodium, when it gives away the electron that it has a positive charge. Chlorine gains an electron, so it has a negative charge. So we have a positive and a negative. Those two balance out. So the compound as a whole has no charge. It's neutral. So ionic compounds form what we call crystals. And a crystal is basically a solid that has a very orderly, repeating 3D arrangement. So the picture up in the corner of the screen is basically what a whole bunch of salt molecules all together look like. So sodium chloride is what salt is, and it is an example of an ionic compound. So that picture, you've got all of those atoms, ions, compounds packed very closely together. Ionic compounds are hard, they're brittle, they also have very high melting points, so that means they need to be at a high temperature in order to melt. Also, when you dissolve them into water, they conduct electricity. A couple types of ionic compounds, acids and bases. Acids and bases, you can kind of think of them as two separate sides of a spectrum. Basically, think of them kind of like opposites. Acids will react with metals and carbonates, which will create a gas, and we call that reaction corrosion. Bases do not do that. Some other characteristics of them: acids taste sour, whereas bases taste bitter. There is something called an indicator, which we're going to talk about in just a moment. And an example of an indicator is something we call litmus paper. Acids will turn litmus paper red, whereas bases will turn the litmus paper blue. We're also going to talk about pH in a moment, but acids have a pH lower than 7, whereas bases have a pH higher than 7. Bases are also sometimes called alkaline. So just so you know, if you see that word, it's referring to something that is a base. So indicators, which I just mentioned a moment ago. An indicator is some sort of compound that will change color when it comes into contact with an acid. Litmus paper is a common indicator, and there are some chemicals that are as well. The pH scale deals with acids and bases. You can measure acids and bases using the pH scale, which goes from 0 to 14. 7 is right in the middle, and it is neutral. It's not an acid, it's not a base. Anything below 7 is an acid, anything above is a base. The closer the pH is to 7, the weaker it is. The further away from 7 it is, the stronger it is. So something that's 1 or 2 or 3, it's going to be a stronger acid than something with a pH of 5. And the same with bases. Something that is 13 or 14 is going to be much stronger than something that is 9. All right. When you mix acids and bases together, you have a neutralization reaction. When this happens, the results are some sort of salt and water, both of which have a neutral pH. So the acid and the base will balance out. And a salt is any ionic compound that is made from a neutralization reaction. So basically it has the positive ion from the base and the negative ion from the acid that were mixed together. Whew. You know, I was worried I would run out of time on this since my video making program has a 15-minute time limit. But I made it! Yay! And now I'm gonna stop talking and let you do your summary. I'm sure your hand is very sore from writing right now, but unfortunately, you gotta write a little bit more. You gotta get that summary done. And as usual, please hang on to your notes. You will have a quiz covering this material sometime soon, so don't lose your notes.